has evolved, matured, has so many famous frameworks to support you write enterprise applications. But why all of a sudden we need another one? Why we need to reinvent the wheel, right? It's really for three main areas we find traditional Java won't be able to fit in. One is the cloud native. Another is microservices architectural style. And is related to this serverless programming model. Now, as I said, big question is why we reinvented this new Java framework, right? It's essentially two things. We try to conquer some deficiencies which Java traditionally have when we try to write utilize cloud computing model. We will just take a little bit deeper in a few minutes. The second, you know what, we want to save the planet. So let's take a look what's happening for the last decades or so, right? There is essentially a critical shift for the enterprise application development. And it took me a while to get used to this new way of thinking. For the last decades or so, we always building long-running applications. We keep modernizing advanced JVM, let becoming more reliable. We let JVM be able to handle a larger and larger heap size. Because one time I remember, we talk about JRocket JVM, we tested hundreds over 300 gigabytes of heap size. We're making is this really a scale up monolithic model. And once we start this training, we're going to keep it running forever, right? It's really the changing for the last few years. We all of a sudden we decided to, you know what, we don't want the big train anymore. We really want a little fun like this. At the same time, fundamentally, we're going to change is that from JIT to AOT. So the just-in-time compiler is really helping you. The JVM, once it started running, gradually it getting smarter and smarter. This model works for long-running applications, but unfortunately doesn't work in a cloud-native mode. So we need something we call ahead of time component. So we want to make this little Java process get instantly smarter from the get-go. Right. Another important new way of thinking is that we always thinking Java application server for the decades or so. We believe this is the only universe, right? Everything we can achieve using Java application server, we can do everything with it. We're not looking at as a Java person, you don't have much chance to looking around what other technology is, right? But nowadays, think about it this way. The new Java framework, we're not trying to make Java another application server as the entire universe. We try to make this Java as a little shining star, little cloud native runtime. We want it become smart from get-go. We want to be small, super fast to get started. Then you may ask, who's going to deal with the application platform, application server responsibilities? You know what? We have this already. Kubernetes, OpenShift, which is the next generation of application platform, or you can say this is a new term, new way. It's called application server. Right? You can see this. It's the difference of the changes.
Evan, could we just get you to turn off your videos so that your machine has better bandwidth, because we're experiencing some cut of on the audio.
Okay. Yeah. Sorry about that. I'm going to turn off my video. And it's always the issue. Are you able to keep up my slide?
Right now, we're just designed to be long running, a picture of people running, but the slides I think should be fine.
Okay. Yeah, exactly. So I'm here. So old school Java application, Java JVM was designed to be long running and the expenses of a startup speed. So at that time, we are not too care about how long does it really a Java JVM get booted up. If it is the heap size is large, like 12 gigabytes, it's more even larger gigabytes. It take, you know what, a couple minutes to get started. This is not surprising. So it's not a big deal. And it was designed for throughput. So the design assumption was that we have a big on-prem machines, has enormous CPU, memory, and we try to use it as much as possible, make it as more throughput. But we never care too much about individual JVM process footprint, because we essentially is that one process, one JVM process, one application instance. We want to just allocate everything, or what we can afford from an underneath physical hardware perspective. Of course, this thinking, this design assumptions doesn't fit the nowadays the cloud computing model anymore. And also, as an interesting fact is here, is that Quarkus, as I said, why we doing Quarkus? Because we want to save the planet. Surprisingly, if you look at this interesting story here, I found it fascinating because when I look at the global digital world consumption, the carbon emission is actually higher than aviation industry. I a bit kind of shocked. I said, oh, Jesus, really? Our computer really eating the world, right? And if you look at that, 5.5% of the world electricity is actually used by the computer, all the digital things, these things. Then we started to think about, hey, is there anything we can help a little bit, right? At least help our next generation, make our planet a little bit green. Then if you look at this, this on the right side is the statistics says, okay, on average, the memory usage, CPU usage, the footprint, Quarkus compared to the legacy platform, legacy framework is significantly lower, right? 2 to 3 times less. Right. Oh, sorry, my bad. I jumped, pushed the wrong button. There we go. So now we talk about what exactly the Quarkus looks like, from where is it coming from, why we're trying to, what's the problem we try to solve. Then let's dig a little bit deeper into this, right? So Quarkus is essentially really is a cloud native Java. Under the hood, really what is most important things for this Quarkus Java framework is it has a reactive core. So it is based on Eclipse Vertex. This is a framework has been there for decades, right? Because of it's essentially not, even with the very novel ideas, it's not quite easy to adopt. So if you may heard about this, and we try to leverage, but this proven efficient Java framework, but make it is much easier for regular developer, Java developer to consume. Next, most important things, we leveraging GraalVM, which is recent innovations, can provide a high performance JDK. It's near native code performance. So what exactly, what do we get from this Quarkus, right? So we'll optimize for developers. We're helping developers, Java developers specifically. We help them to write better code, easily deploy it, and get a more efficient code, help them easy to deploy to the cloud. Then you may wonder, is this something new? Is whenever something new comes up, people always wondering about, is this reliable? Is this a lot of bug free? Is a lot of trouble with that? Actually, Quarkus, most of the core of the Quarkus is based on standards, based on all the existing battle-proofed Java frameworks like Vertex, like many of the standard from Eclipse micro profile specifications, and to make this more easier for developer to consume the latest technology like reactive, there's a specific model API designed for you to allow you just change your programming model easily without much of hassles or complexities under the hood. You need to understand how the callbacks work, such as like a Vertex brings to you, right? And at the same time, to increase the developer productivity, and there's built into the like you don't need to do a tons of configurations. Once you save the code, automatically reflect changes and the runtime. And also you see that we were talking about one of the key features of the native image. To build a native image is no complicated than previously you built a Java. Look at just a little bit of example. How easy is you are writing a imperative code on the left side versus you're writing some more contemporary, fancy reactive streaming codes, right? It's almost identical to you. So the developer much easier to adopt, to leverage the new technology, make your application running better and faster. All right, I talked a lot. Now we can pause for just a little. We can have a little play with it, right? Not super sophisticated demo, just small enough to show what it is. Let me switch to my terminal. Are you able to confirm? Can you guys see my terminal? Is this
Yep.
Is this big enough for you guys?
Yeah, it's good.
All right. So, good. Thank you. I just do like say this. I do a Quarkus command line. I can see this. So it's come with a very convenient command line to called Quarkus. You can see there's a lot of command come with it. So let's start from beginning. How am I going to create a simple REST API applications, right? There's three different type of applications you can create. You can create a CLI application. You can create a Quarkus extension. And let's make it very simple, straightforward. So we create application. So I give a package name, like say Redhat Demo, and I call it Quarkus Y, right? Create instantly. So let's get to take a look what it looks like. So it generates a typical Java applications. You can see that necessarily come with the Maven build file, POM file, all those things. Then of course you can see that they give you a Docker files, allow you to create container images later on easily. But let's take a look at this. So I'm going to launch my VS Code. Just to take a look at. Very simple, straightforward startup applications. Right. So let's spin it up. right? See how it works. Only thing I need to do is to start Quarkus as a dev mode. I just started to doing the typical thing. So you can see that you can always go back to the traditional Java way using all the Maven command, do all the things. But this time, I just try to show you a more convenient way. So purely using the Quarkus CLI. But under the hood, you can see that the Quarkus CLI is just a wrapper, a shortcut for all the Maven command. So is under the hood is actually around the Maven. But if you don't like Maven, of course, there is another builder options you can use, or Gradle for sure. Now you can see that I started this Quarkus get started. So this is in the Quarkus dev mode. So dev mode, what it comes with it is, first of all, it has the hot reload. Whenever you make a change to your source code, it's reflected right away. And also they have a tons of, for example, they have this dev terminal. There is some options such as continuous testing. This is something we can do in the future sessions. But take a look. I'm going to start my browser. You see I jumped to the browser session now. Can you see that? Okay. I assume everyone's be able to see my screen. So it's just showing a default index page for that REST API application I have just created, right? This is very simple, straightforward. It's not, if you look at you see the code is just return you a simple string, right? But this is not a point. The point is the dev mode comes with some utilities for you, like this dev UI. They will facilitate, help you to work with Quarkus more efficiently and easily. For example, this configuration editor, it gives you all the possible configurations property files. Think about it. Old school, you don't need to check the reference or check the documentations, figure out what is exactly the right configuration properties I need to use. And second thing is most interesting thing is look at this. I have a specific REST core console. So this is a little a tile dedicated section dedicated for REST API. It has an internal scoring system, allow you to say, hey, how good at my code is written. It looks like supposed to be 100%, right? Score. So I'm trying to figure out, let's say that's why I'm not scoring well. Is of course I got a 0% here. What's wrong with it? So it's telling me your code was written is not that efficient. Okay, so what is this? Need a worker thread dispatch. All right, because default, let's go back to the code. By default, this is a purely simple blocking code, right? Request comes in, waits, and blocking the thread. So to turn this into a reactive paradigm, I can just simply add an annotation called non-blocking, right? Let's save this. Go back. Do this. Refresh. Data. You can see that I improved my score. Looks like my little API becoming a little bit greener. All right. Okay. And go back to now. I'm going to quit the dev mode. So let's take a look at the footprint of this. So footprint. Let's do a build. Right. Let's do a build and start it. This is the pure, simple, normal JVM mode. I'm not building the native image yet. Here you go. We have a once we have a Java jar built, I'm going to run it as a JVM. not as a native code. Let's take a look at how long does it take to boot up, and how long does it, what's this the footprint, the reserved memory. Okay, it's a build. So I do Java, let's do targets, what do you call it, Java, it's Quarkus. You can see this, yeah, it's not too bad. It's give us elephants the 400 hundreds of milliseconds to boot up. And let's take a look at what exactly the on the other screen. You can see that this is really this process take over 104 megabytes. Right? So for non-native image, Quarkus still be able to boot relatively quick, so 100 milliseconds, and take over 100 megabytes of footprint. Let's compare it with the native image build. So since the native image build is as simple as this, I just do a build with the just a switch option say native. That's the only thing you need to do. It will going to take some time. It will take like 2 or 4 minutes to build. Given the time we have, I'm not going to do a live build native image right now. Let me use a let me just boot up a pre-built native image and see how it works. You can see this for boot up a native image is 10 times faster. We're talking about it was 100 milliseconds. Now this is exactly the same code. We're getting tenths of a milliseconds. And let's take a look what my footprint is, memory footprint. Look at this. Is 36 kilobytes. Magnitude shrink, right? That's all I am be able to show today. Then let's back to finish our talk a little bit. So we have seen this impressive startup time, right? Native mode is we be able to get it started to tens of milliseconds, compared to OpenJDK Java hotspot mode is hundreds of milliseconds, but it's still way faster than the traditional stack without Quarkus optimization. We're talking about seconds. And also the build process is a little bit different. Why I'm not able to show you the native build is because native builds requires ahead of a time a native compilation. So we're trading the build time, so make it is smarter. So we don't rely on the JIT, let the process gradually learn, optimize the code. So we and the build time actually we optimize the code. So that's what I'm saying is that the Quarkus be able to get smarter and get go. So we be able to, it's small, it's be able to start up quick, and once it gets started, it's already optimized. The trade-off is take a little bit of long time to build a native image. So we have seen this. The Quarkus native VM with native VM, where this old statistics telling us just the REST API is taking 13 megabytes. We have seen it's even smaller. It's 36 kilobytes, right? OpenJDK one is relatively on the same bar. We were seeing that 104 megabytes. So you can see this is really the Quarkus. What Quarkus bringing up is supersonic, subatomic Java, fast, small. But most importantly, it's still reliable, as we talked about earlier. It's based on the proven Java frameworks or libraries, which has been tested for decades, right? It have an active community to support. So that is why we have seen customers really put Quarkus code in production even before Quarkus 1.0 launched, because they understand the core, like the Vertex core, they understand the libraries we were using, which is nothing new. It's just we just repackaged it, optimized it with GraalVM. And by adding all the automated capabilities like dev service, dev console, dev hot reload, continuous testing, it's definitely significantly improved your productivity. Last but not least, of course, you can see that we have a lower memory usage, faster startup, most important, high density. So now you can see that we can pack more applications, processes inside a traditionally like a host, a machine, or even VM. Let's look at what's the overall landscape where the Quarkus is fitting. So Quarkus is a part of what we call Red Hat runtime. So now Red Hat runtime is part of what we call a Red Hat application foundation. So Red Hat application foundation consists of Red Hat runtime and Red Hat integration. So Red Hat runtime is Quarkus definitely a foundational core component for it. On top of it, we have like say data grid, AMQ brokers, single sign-on kick clock, with all these utilities. A little bit to finish up with my introduction of this. Somebody may just get interested, say, hey, what exactly the numbers? So what are really the value we get from theirs? There is a lot of studies and papers published by customers itself or by individual researchers like this IDC. You can see that they give you this much of a 3-year return. This is the paybacks. The money dollars you can save, quite impressive. But if you if you would like to trust the real customer feedbacks, definitely we have a couple of them. The published available references like the Vodafone. This is one of the European telco company. So they are the early adopters for Quarkus, our Quarkus framework. They were saying they prove that 60% boot time increase, right? 40% is CPU savings, right? We have a smaller, faster, smarter, and they apply Quarkus to all of their new projects. That's amazing. There's some other customers already using this, like say this from aviation industry to telecom to IT industry. They all see the similar pattern, saving resources faster, and of course, in return, they get more value from this new framework, and also indirectly, of course, saving the planet. And this is what is really a few of them are Quarkus in production, but not limited to this. So now the last thing. If you got interested, you really want to try it, it's very easy to try. Get over there. There's a couple of sites you can try Quarkus. You can do code.quarkus.io, which is community version. And if you do code.quarkus.redhat.com, that will be supported version from Red Hat. We call it the Red Hat build of Quarkus. All right, thank you. Well, I'm just a little bit over the time. I really hope you enjoy this, and definitely see if you have any questions or interested in get some more deep diving into specific areas of Quarkus. I'm more than happy to help.